Alright, hello everyone. So our first video was about graphing these by hand. However, we saw that there was a lot of symmetry in the graphs, and so graphing by hand can be kind of difficult or just time consuming because there's a lot of points you have to plug in. So instead we're going to try and look at these, we're going to use our calculator and see some patterns along with them. So the graph that we looked at earlier, I have it here, 3 plus 3 cosine theta. So we had this 3 and the 3, they were the same number. And when that's the case, we call it a cardioid. And we say that it kind of looks like a heart because this graph comes to a nice point here. It's symmetric. And depending on the numbers, this point might get stretched down or up and make it more look like a traditional heart. But we call it a cardioid. So it's any polar graph that looks like or has this form. So let me get a highlighter. So either a plus a cosine, a minus a cosine, a plus a sine, a minus a sine. So any one of those graphs or equations like this, it'll have a similar looking graph. So let's go ahead and look at it, and let's look at our calculator to see how we get that. So I'm going to pull up my calculator. Let's say I'm at my home screen first. So make sure first we go to mode. We want to be in polar. Some of us are probably in function right now, so make sure we tab over and make sure we select polar and that's highlighted. Also, you want to make sure you're in radian mode. I know we were in degree for chapter 8, so let's make sure we switch over to radian mode. Now, when I press my y equals, I get that R1 or R2. So instead of having y equals, it is now R equals. And I can go ahead and type this right in. 5 plus 5 cosine. And now normally we press this button, that is our x. On this calculator, it's actually just any one of our variables. So since we're in polar, the calculator already knows that our variable is theta. So when I click it, it already picks my theta. I close my parentheses. And now, if we look at this, step 2 says let's press and go to zoom 6. So 6 is our standard. So remember, you could tab all the way down to 6, or you could just press number 6 and it'll take you there. And when we get that, we get this graph. So, like I said, this one looks a little bit different. It's stretched down a little bit more, so it looks a little bit more like a heart. I'm going to try and capture this and put it in for us. There we go. Okay. So now we can still do stuff with our calculator, which is kind of nice. Just like before, when we want to find the intersection or find the value of points, we can still do that. Here, let's go to second calc, or second trace, which is calc, and I can find the specific value at some point. So when we did this before, you plug in an x value, you get out a y. Here we're going to plug in theta, and we're going to find our r value. So if I type in 0, enter. No, 0 is when we are this direction from the pole. And then this would be like if we plug in pi over 2, pi, 3 pi over 2, and so forth. So if you look at our graph, we get the point. It is at 10. Our r is 10. I got 10 units out. So I can go ahead. Nice big 10. Let's do that again. And I'll put in pi, so second up arrow. And I get 0. So my value, I've gone 0 in that direction. So that's my 2 points. Alright, so this is just a general form, kind of a little discovery through the calculator how to find these graphs. So let's do that with some other equations. Pull my calculator back out. Now I have 3 plus 3 cosine. I'm going to graph. And if we look at this graph now, screen capture it for us. So that's what that one looks like. Let's do all 3 of these, and then we're going to kind of look and see what we notice. The next equation is 4 minus 4 cosine theta. And I could do my zoom 6, but since we're already there, it's going to be okay. It's going to be the same thing. So here we go. Put this in. And the last one, which is 5 minus 5 sine. Oh, 5 minus 5 sine theta. What is it? Zoom 6. All right, so we have these 3 separate graphs now. So now we kind of want to see like what do we notice a little bit? Maybe going back to the first page also. We notice that in the 2 directions, I'm at 10. So I went out this way 10, and I've gone 0 in the y or in the pi direction. So you kind of ask yourself, well, what patterns might we see? So one thing you might notice is here I've gone 1, 2, 3, 4, 5, 6. So when theta so it just takes me a little bit of time. I don't have the nice stylus computers to draw in here, so I'm just going to type things out. So when we're in the theta equals 0, I go to r equals 6 on this case. When theta equals pi, I'm at 0. Here, let's copy this. And this time, when theta is 0, so I'm out in this direction, I'm at r equals 0. And when theta is pi, I'm at 1, 2, 3, 4, 5, 6, 7, 8. My r is 8. And remember, it's even though it's to the left, it's not negative 8, because if I went pi comma negative 8, I'd go in pi this direction, 8 units. But since if I had a negative 8, it would flip the direction, so it would be put over here. So this is still just theta is pi, r equals 8. And for this last one, also do when theta is 0, 1, 2, 3, 4, my r is 5. And when theta is pi, my r is still 5. So let's look at these first two really quickly. If you notice, let's look at the structure. So they have the same A number, 3, 3, or 4, 4. So they do fit in that cardioid pattern, and they do have that cosine with it. So if you notice, these, when it's cosine, the graph is kind of on this what you normally would call the x-axis, is kind of more horizontal than vertical. And then when we switch to having a sine, it is vertical. That point, it gets pulled down vertically versus horizontal. So one thing to notice is that cosine will go left and right. The sine would go up and down. And then you kind of decide the way you look at it is what numbers these are. So here, I'm adding. So when I plug in 0, I can add the 2 to see. Okay, I'm at 6. And then when I'm in the pi direction, it's the opposite side, 3 minus 3, which is 0. And same thing for this B, and same thing for the C. So I have a little bit of it kind of pulled together, if we can see this a little bit better. So if my R, so if I have, this is for my cardioids, if it is A plus A cosine, like that first example, it's a horizontal kind of looking graph, and I am adding A plus A to get to the end. And then I know I'm also at the pole. So my one point, I'm at the pole, the other point, I'm when you add the two together. And then you can kind of pick the other 2 points. You can even look here on this graph. I can add on to here. When theta is pi divided by 2, you can see I'm at 3. And when theta is 3 pi divided by 2, my r is also 3. So there's 4 really nice points you can see, and if you notice, look, this 3 is the same as my a value. Here, my theta of pi over 2 would be 4, theta of 3 pi over 2, which is also my a value. So we have these 4 really nice points, which is a plus a is at my pole, 0 comma a, and 0 comma negative a, and then I'm at the pole. Now, if it's negative, it just gets flipped over this axis right here. It gets flipped over that axis. And now, if it's the sine, like we said, for cosine, they're horizontal. For sine, they are vertical. And now if you notice, if it's a negative sign, it just gets flipped over this axis now. So there's a lot of symmetry in these graphs. Like I said, these are the graphs of cardioids. We're going to look at another graph also in just a few minutes. But I want you to, the main point we want you with these graphs is just to be able to look at them and kind of identify what type of graph they are. You will be able to have your calculator the whole time. So if you can plug this into your calculator and kind of identify some shapes and maybe pick out some points, you'll be in a really good spot.